We're going to look at some examples that are worded problems. So let's have a look at this one. We've got some ticket sales for a day showing at the Royal Cinema are given by the matrix shown. So we've got our rows with the matinee, so the afternoon performance, evening, and the late performance, and then how much it costs for adults at each of these sessions, and then the concession if you're a student or child. If an adult ticket costs $15 and a concession ticket costs $10, draw a 2x1 matrix showing the ticket price. So it would look something like this. Okay, so let's put that in perspective. So we've got our adult and our concession, and we know that they're $15 and $10. There's our matrix, and if we wanted it to look like that, it would. Use matrix multiplication to show the daily takings. So we need to work out with an adult at 15 and a concession at 10, and then we've got these different values for the different sessions, what it would actually look like. So let's have a look at this. We've got 2 rows and 1 column. So it's a 2x1 matrix. So we've got to remember our rules, which we had in the last video, that we must have in our matrix, column A of the first must match row B of the second. So let's just work out the possible options. So if we look at the ticket first, 2x1, and then we multiply that by our our 3x2. So let's see if that actually works. Can we actually make this work and multiply? So if we look at this, these two must match. They don't match. These ones do. But the first rule, which is column A must match with row B, if that isn't satisfied, then that doesn't work. Let's have a look at the other option. I'll just put it up high. So 3x2, which is this one, multiplied by our 2x1. Column A must match with row B, or the row B being the second matrix. That's a tick. And then our resultant matrix must be a 3x1. So that's going to work. So let's do that. So if this is our 3x2, let's write that. 18, 8, 20, 14, and 27, 15. And then we're going to multiply that by this one, 15 and 10. This will work, and our resultant matrix will have 3 rows and 1 column. Okay, so let's actually do that. So remember how we do that is it would be 18 times 15 and 8 by 10 plus 8 times 10. And then again 20 by 15 and 14 by 10 and 27 by 15 and 15 by 10. So there's our working column. And then if we were to solve that, 18 by 5 plus 8 times 10, put them in brackets so you know which bit goes first. That would be $350. Then the second row would be $440. And then the third row would be $555. So we've got that. What does that actually mean? So that's about the money, the tickets coming in. Okay, so that's for the matinee, that's for the evening session, and that's for the late session. Explain what the different elements, so remember the elements are the numbers in your matrix. So it represents, if we look at row 1, 2 and 3, it's the total takings in terms of your ticket money from the matinee. And then row 2 is the total takings from the evening session. And then row 3, this one here, is the total takings from the late session. And you could add them all up, 350 plus 440 plus 555, and you could get the total money that you get in, say, for that week. Let's have a look at another example. We've got a football example here. We've got the final score of an AFL football match in goals and behind is given below. We've got Geelong is 12 and behinds are 10 in terms of goals and behinds, and Hawthorn is 11 goals, 15 behinds, but we actually haven't got the total score here. We're going to actually work that out. If we know that a goal is worth 6 points, and we know that a behind is worth 1 point, we could do a matrix of that, a 6 by 1, a 2 times 1 matrix. Interpret your final matrix, who won the game and by how much. So we've got to try and work out which way we're going to multiply them. So let's have a look at this. Let's have a look at multiplying the 2 by 1. So let's multiply the goals and behinds by this one. You can see 2 rows by 2 columns, 2 by 2. Let's see if that fits with our rule that we learnt. No, they're different. It doesn't work. So we can't do it in that order. Let's have a look at the other way. Let's look at it in terms of our goals and behinds, 2 by 2, and let's multiply by our goals and behind, which is our 2 by 1 matrix. Yay, that works. We've got the same number. So there's a tick. Let's have a look at our rows of the first one and our columns of the second. This will tell you what the matrix will look like. So that's actually going to work. So let's do that. Let's do our 12 and 11, 10, 15 matrix, which is our 2 by 2. Let's multiply that with our 2 by 1 matrix, which is in fact this one. We should end up with a matrix that has 2 rows and 1 column. So if we have a look at this, the rules. First element with the first column, and like that. So it's going to be 12 times 6 plus 10 times 1, and then it's going to be 11 times 6 plus 15 times 1. And this will actually tell us eventually our total score. So 12 times 6 plus 10 times 1 actually gives us a value of 72. 11 by 6 plus 15 times 1 gives us a value of 81. So even though they're not written down, we know the first one is Geelong and we know the second row is Hawthorn. So from that, I can see that Hawthorn, its total score is 81 and Geelong is 72. Interpret your final matrix. That tells us that Hawthorn has the highest score. Who won the game? Hawthorn, and by how much? 81 takes 72 is 9 points. And there you have your answer. So make sure that you're copying these things down into your book. All right, in your textbook, you need to have a turn yourself. Let's find the page, which I haven't got prepared earlier. Okay, on page 35, question 30. Actually, we might go 29 onwards to You might just go to 31. So doing a couple of worded problems will assist you there. Now, on page 36, you'll notice that there are mixed calculations there. Have a go at doing some of those. So there's question 33, 34. There's a whole lot there. If you've got plenty of time to spare and you're working ahead of everybody else, I would suggest 33 to 40 would be a really good mix of everything that we have covered so far. So have a go at all of those.